First, let's rewrite this pseudocode into a C++ program. So here is the rewritten code. First, we included the IOStream library, which is necessary for input and output operations in C++. It allows the use of stdcout for printing to the console and stdcin for reading from the console. Next is defining the main function, which will be the entry point for our C++ program. The later execution of the program starts here. And then, we declared the integer variable j and initialized its value to 0. This variable is used later in the calculation. Next is declaring the variable k with the value j plus 13 divided by 27. But we will be using the data type double to make sure that our program can handle decimal points accordingly. Our program then starts a while loop that will continue to execute as long as k is less than or equal to 10. Inside the loop, k is incremented by 1. This ensures that eventually k will exceed 10 and the loop will terminate. In each iteration of the loop, an integer I is calculated using the expression 3 times k minus 1. Note that the value of I is recalculated in each iteration, but it is not used or printed anywhere in the given code. This means that the calculated value of I does not affect the program outside of the line. And then, these curly braces closes the while loop. Outside the loop, you may write an additional code which can be added to the program after the loop finishes. And then, the return 0 from the main function indicates that the program has executed successfully. And lastly, these curly braces closes the main function. Here is the summary of execution. First, j is initialized to 0. Then k is calculated as approximately 0.481481. The while loop runs as long as k is less than or equal to 10. And then inside the loop, k is incremented by 1 in each iteration. An integer I is calculated in each iteration but not used. Then when k exceeds 10, the loop terminates. After the loop executions, the program ends successfully by returning 0. This program effectively demonstrates a simple loop with floating point arithmetic and conditional control flows.
Hello everyone and welcome to today's video, where we'll dive into understanding a pseudocode segment and its implementation in Java. Let's start by breaking down the pseudocode segments. In this pseudocode, we have a simple algorithm that calculates the value of k based on some initial value j, and then enters a loop where it increments k until it reaches a certain condition. Now, let's translate this pseudocode into Java code. In the Java code, we initialize j with some value and calculate k using the same formula as in the pseudocode. Then, we enter a while loop where we check if k is less than or equal to 10. If it is, we increment k by 1 and calculate the value of I based on the updated k. Now, let's understand each part of the Java code. First, we start by initializing j with some value. Then, we calculate k using the formula j plus 13 divided by 27. Next, we enter a while loop where we continuously check if k is less than or equal to 10. Inside the loop, we increment k by 1 using k equals to k plus 1. By using the formula 3 times k minus 1. The loop continues until k is greater than 10, at which point it exits the loop. And there you have it. We've successfully translated a pseudocode segment into Java code, understanding each step along the way.
Here are the pseudocode rewritten using a loop structure in Python. J equals 0, hashtag assuming J starts from 0. K equals J plus 13 divide by 27. While true, if K greater than 10, break K equals K plus 1. I equals 3 multiplied by K minus 1. Print out of loop. In this Python code simulates the behavior of the provided pseudocode. Here's how it works. Number 1, initialize J and calculate K using the given formula. K equals J plus 13 divided by 27. Enter a while loop that continues indefinitely while true. Check if K is greater than 10. If it is, break out the loop break. If K is not greater than 10, increment K by 1. So K equals K plus 1 and calculate I using the formula I equals 3 multiply K minus 1. Repeat steps 3 and 4 until the condition K greater than 10 is met. And print out of loop once the loop is exited. In this Python code, uses a while loop to repeatedly executed the block of code within it until the condition K greater than 10 is met, simulating the behavior of the provide pseudocode.
So before we discuss which language has the best writability, the best readability, and the best combination of the two, let us first discuss the writability and readability of each language provided in the context of the given code. First is C++. For writability, C++ provides a good level of writability with its syntax. The code is concise and expressive. However, memory management and syntax intricacies might make it slightly less writable compared to other languages. And for readability, C++ code might be less readable to beginners due to its complex syntax, especially with features like pointers and memory management. However, for experienced developers, C++ code can be quite readable and well structured. The second one is Java. For writability, Java offers a good writability with its straightforward syntax and built-in memory management, such as garbage collection. The code is easy to write and understand, making it suitable for developers on varying experience levels. And for Java's readability, Java code tends to be highly readable due to its simple syntax and strict conventions. The use of meaningful variable names and the absence of pointer manipulation contribute to its readability. And the last one is Python. For writability, Python excels in writability due to its clean and concise syntax. The code is often shorter and more expressive compared to C++ and Java. Python's dynamic typing and high-level abstractions make it easy to write code quickly. And for Python's readability, its simple and intuitive syntax closely resembles natural language, making it easy for beginners and experienced developers alike to understand and maintain Python code. So in conclusion, for the given code, Python likely has the best combination of writability and readability. Its clean syntax and high-level abstractions make it easy to write and understand, making it suitable for developers of all skill levels. Java also offers good writability and readability but might require more verbose syntax compared to Python. C++ can be powerful but might be less readable and more complex due to its lower level features and syntax intricacies.
Rewrite the following code segment by using C++ language. The first condition, if key is 1 or 2, calculate g as 2 times key minus 1. The second condition, if key is 3 or 5, calculate g as 3 times key plus 1. And the third condition, if key is 4, calculate g as 4 times key minus 1. And the last condition, if key is 6, 7, or 8, calculate g as key minus 2. So here is the rewriting code segment into a C++ language. In this C++ code, the else-if statements are used to ensure that only one condition is executed based on the value of key. The variable g will be used to store the result based on the value of key. And to avoid confusion, we ensure to clarify the C++ to generate better by using else-if to make it explicit that only one of the conditions will be executed, as shown in the rewritten version. So the first condition is if key is 1 or 2, calculate g as 2 times key minus 1. It checks if key is either 1 or 2. If true, g is assigned the value of 2 times key minus 1. For example, if key is 1, then g will be 2 times 1 minus 1, which is equals to 1. And if key is 2, then g will be 2 times 2 minus 1, which is equals to 3. The second condition is if else. If key is 3 or 5, calculate g as 3 times key plus 1. Then it checks if key is either 3 or 5. If true, g is assigned the value of 3 times key plus 1. For example, if key is 3, then g will be 3 times 3 plus 1, which is equals to 10. And if key is 5, then g will be 3 times 5 plus 1, which is equals to 16. The third condition, it is else if. It checks if key is 4. If true, g is assigned the value of 4 times key minus 1. For example, if key is 4, then g will be 4 times 4 minus 1, which is equals to 15. The fourth condition is else if. If key is 6, 7, or 8, calculate g as key minus 2. Then it checks if key is 6, 7, or 8. If true, g is assigned the value of key minus 2. If key is 7, then g will be 7 minus 2, which is equals to 5. And if key is 8, then g will be 8 minus 2, which is equals to 6. Using else-if ensures that once a condition is met and executed, the subsequent conditions are not checked. This is important for performance and correctness, especially when multiple conditions might be mutually exclusive, as in this case. The if statements in the original code would check each condition independently, potentially overwriting G multiple times if key match more than one condition, which is not desired behavior. And the original code reads as a series of independent if statements that each specific condition for the variable key and assign a value to the variable g based on the value of key. Because these are independent if statements, multiple conditions can be checked even if one condition has already been met.
In Java, here's the code segment can be rewritten using a multiple selection statements. or switch statement as follows. First, the code starts with the switch statement, followed by the expression key. This expression is evaluated, and the value of key is used to determine which case to execute. In the first case 1 and case 2, if the value of key is either 1 or 2, the code inside the case block will be executed. In this case, k is assigned the value 1. In the second case 3 and case 5, if the value of k is either 3 or 5, the code inside the case block will be executed. In this case, I is assigned the value 3 times k plus 1. In the third case 4, if the value of k is 4, the code inside the case block will be executed. In this case, j is assigned the value 4 times k plus 1. In the fourth case 6, case 7, and case 8, if the value of k is either 6, 7, or 8, the code inside the case block will be executed. In this case, j is assigned the value k minus 2. If none of the above cases match the value of key, the default case is executed. This is optional and can be used to handle any other cases that are not explicitly mentioned. Certainly, the code segment determines which case to execute based on the value of key using the switch statement in Java. The value of key is compared to the values specified in each case statement. If the value of key matches any of the cases, the corresponding case block is executed. In the given code segment, the value of key is compared to different cases using the case statements. Depending on the value of key, the corresponding case block is executed, and the code inside that block is performed. This allows for different actions to be taken based on the value of key using a structured and concise approach. After the code inside the case block is executed, the break statement is used to exit the switch statement and prevent the execution of subsequent case blocks. This ensures that only the code corresponding to the matched case is executed. If none of the cases match the value of key, the default case is executed. In this code segment, there is no explicit default case specified, indicated by the absence of a default level or code block. However, you can add code inside the default case to handle any other cases that are not explicitly mentioned. By using a switch statement, the code can evaluate the value of key and execute the appropriate case block based on that value. This provides a more structured and concise approach compared to using multiple if statements.
Have you ever wondered how to simplify complex code segments in Python? In this video, we'll explore how to rewrite a multi-condition code segment using a multiple selection approach for better readability and efficiency. Let's take a look at the original code. This code segments contains multiple if statements with different conditions. We can simplify this using a multiple selection approach. First, let's understand the logic behind the code. The code segments assigns a value to variable j based on the value of variable k. The original code checks various conditions for k and assigns values to j accordingly. For example, if k is 1 or 2, j is assigned a value of 2 times k minus 1. Similarly, other conditions are checked. Now, let's rewrite the code segment using a multiple selection approach in Python. Instead of using separate if statements for each condition, we use the elif statement. This statement allows us to check multiple conditions sequentially. Elif stands for else if. It checks the condition only if all preceding conditions evaluated to false. If the condition is true, the corresponding block of code is executed, and the rest are skipped. Let's see the rewritten code in action. As we can see, the rewritten code achieves the same functionality as the original code, but in a more concise and readable manner. In summary, by using a multiple selection approach with elif statements, we can simplify complex code segments, improving readability and efficiency.
So here is the rewritten code. First is initializing the variable j with a value of 3. And then, we initialized a for loop where I is equals to 0, I is less than 3, and I plus plus. This loop will iterate I from 0 to 2. The condition I less than 3 ensures the loop runs up to 3 times unless we manually adjust I within the loop. So for us to avoid using break in the program, we converted the switch statements into an if-else statement. For condition 1, if j plus 2 equals 3 or 2, decrement j by 1. And for condition 2, if j plus 2 equals 0, increment j by 2. And if neither condition is met, set j to 0. So the next step is checking the value of j. If j is greater than 0, instead of using break, set I to 3. This makes the loop condition I less than 3 false, which effectively exits the loop. This method avoids using the break statement while achieving the same result. And else, if j is not greater than 0, update j to 3 minus I. The loop runs 3 times or until j becomes greater than 0, at which point it forces an exit by setting I to 3. This method effectively removes the need for a break statement while preserving the original logic of the code.